desk.
Yeah.
So fun.
What are you doing? Oh, the Emerald City.
Yeah.
You're shiny.
What is Emerald City? I don't even know.
Oh my gosh, it's part of the
The Wizard of Oz.
Wizard of Oz.
I don't know if I've ever seen it.
Look, the Emerald City is right there.
Where? Oh, I don't think I've ever seen The Wizard of Oz. I think I might have played, but I think I fell asleep.
I wanna go see it sometime. If it comes back
Wait,
to
did
there,
you
I'll
see the
totally
person
go.
that
Okay,
had
we're on
like a full green face paint?
Evaluating determinants and applying something called Kramer's rule. Okay, when you are dealing with matrices, sometimes we have to find a determinant. The reason we're gonna find determinants is so that we can solve some stuff later, okay? And we'll talk about that, but today we're just gonna focus on how to find the determinant, then we'll talk about when to apply the determinant later. Okay? So associated with each n by n square, or n by n, okay, matrix is a real number called the determinant. The determinant of a matrix A is denoted by DETA or by the absolute value of A, okay? Determinant of a 2 by 2 matrix. To do determinants, you multiply down diagonally, okay? And you get a number, and you add all of those diagonal numbers together, and then subtract from them the diagonals multiplied the opposite direction. We're gonna do several, okay? You need to write it out, or else you won't do it right. There's two ways to do it, one's with writing it out, and one's without writing it out. Personally, I always use the one without writing it out because I don't like to spend more time writing it out, but a lot of times you'll make more mistakes if you do it that way. It just is up to you. So we're gonna use this board probably a lot today too. So let's look at this. When you have a 3 by 3, you go like this. You multiply row A, E, and I together. You add it to B, F, and G, and you add it to C, D, and H multiplied together. From that, you are subtracting the opposites, G, E, C, H, F, A, and I, D, B. Okay, see how they rewrote these two rows out there so that they can do it? Because the other way is you have to loop things, and then it can get confusing. So we're gonna take a look at this. If I wanna do the determinant of the first one, 5, 4, 3, 1, okay? This is easy. I don't need to rewrite anything out because to find the determinant, I literally go 5 times 1 is 5, minus 3 times 4, which is 12, okay? And what's 5 minus 12? -7, okay? But what did we, yeah, -7. So your determinant is -7. Cool? So finding the determinant isn't extremely hard. It's just gonna take us some time to do. And we can use determinants to find area, which is what we'll eventually get to. So this is -7. 2 by 2s are super simple. Okay. 3 by 3. 2, -1, -3, 4, 1, 0, 3, -4, -2. Okay? To find the determinant of this, I need to rewrite these first two columns back over here. 2, -1, 4, 1, 3, -4. Okay? And what I do to find this determinant is I come here and I multiply 2 times 1 times -2. What do you get when you multiply those together? 2 times 1 times -2.
Oh, -4.
-4. Okay? And you're adding it to -1 times 0 times 3. What do you get when you do that? -1, 0, 3. 0. Then you add it to -3 times 4 times -4. What's -3 times 4? And what's -12 times -4? 48. Okay, 48. From there, you are subtracting. Okay. You're going to subtract 3 times 1 times -3. What do you get? 3 times 1 times -3. -9. Plus -4 times 0 times 2. -4, 0, 2. Good. plus -2 times 4 times -1. -2 times 4 times -1. -2 times 4 times -1. 8. Okay, so here, what is -4 and 48 together? 44, right? So I get 44 minus, and what's -9 and 8 together? -1, right? 44 plus 1, and your determinant is 45. Okay, so my determinant is 45. We use the determinant to find areas of things. When we have vertices, okay, or when we have 2 of the 3 vertices, we can use it to find area of things. Or if we have 3 of the 4 vertices, so we can use it to find the area of a triangle. The normal formula for an area of triangle is what? Times 1/2. Okay, a half length times width. Half base times height, okay? So if we have 2 vertices, or 3 vertices of a triangle, we can solve the area using determinant, basically, okay? You're gonna take the area equals the plus or minus 1/2 times the determinant. Here's why plus or minus. You're going to choose if you're multiplying by -1/2, if the answer is negative, because can you have a negative area? No, so if my determinant comes out negative, then I need to multiply by -1/2 to make it positive, okay? If my area already comes out, if my determinant already comes out as positive, then I'm just gonna multiply by +1/2 because your area is positive and we wanna keep it that way. So, they use this a lot of times with ships and seas and like courses and stuff that you're plotting out, okay, to see how far you're traveling or what the area of something is you're covering. So off the coast of California lies a triangular region of the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting Bodega Bay and Farallon Islands and Ana Nuevo Island, as shown. No idea where these places are. So in the map, the coordinates are measured in miles. Use a determinant to estimate the area of the region. What are the 3 points that we're working with on this? What are the 3, where's Farallon Islands? Where's 0, 0? That's one of my points I'm working with. And then you're working with what? -141, and then what's my other coordinate? 38, -43. Okay, so to find the determinant, this is x1, y1, x2, y2, x3, y3. Doesn't matter what order you put them in, okay? As long as whichever one you write down goes together, okay? So you go 0, 0, -1, 41, 38, -43. You always come and make it a 3 by 3. To make it a 3 by 3, use a filler number of 1. Okay, so 1 is your next number. Remember, we are going to multiply this by either plus or minus 1/2 at the end, okay? So to do the determinant, I'm gonna recopy these 2 rows over, or 2 columns over, I mean. And then I'm going to do some math from there, okay? These are big numbers, so I'm gonna get my calculator. So to find the determinant, I first start by going 0 times 41 times 1. 0 plus 0 times 1 times 38 plus 1 times -1 times 43. 43. Minus, okay, 38 times 41 times 1. So 38 times 41 times 1 is 1558. Plus, you said the next 2 are 0? 43, 1, 0, good. Plus 1, 1, 0, so 0, good. Okay, so I end up getting 43 minus 1558, correct? So 43 minus 1558 gives me negative 1515, yes? Okay, that is my determinant right now. I have to take that determinant and I have to multiply it by what? To find area of this triangle. Positive or negative? Negative. I need it to be a positive number. So multiply it by 0.5, and you should get that it's 757.5 miles squared. Because you're doing area, so there should be a measurement with it. Okay? So you're using the determinant to find areas of triangles. The determinant equation is inside the absolute value. You take it out of the matrix and you put it inside the absolute value sign. But it's not absolute value. It's just the sign looks like absolute value. Does that make sense? So the determinant can either be written like, if they're asking for it, they'll either write it as DETA, determinant, or they'll write it as this, which means determinant also.
Bring your quizzes back. Or between these.
Yes, because everybody took it. I just had to think for a second. I'll give it back to you, remind me it's okay. So actually, I think we're gonna stop there today and we're gonna split this into 2 days. And we're going to do, after we learn how to do the determinant today, tomorrow we're going to apply the determinant to solve some things. What do you do with this? It's never gonna be used and that will never be used. Okay? I'll show you one other way to do this too, the determinant. But the reason we're finding determinant is because you know how you do substitution and elimination to solve for x and y and z? You can use the determinant to solve for x, y, and z. Okay? So it's another method of using that same thing. Now, let me show you one more determinant, and I'm gonna show you a way that's not like this, where you don't write it out and you can solve. But you can choose which way you wanna do, okay? So let's do these numbers. Let's go 4, -1, 2, what else is on here? -3, -2, -1. And let's go 0, 5, and 1. Okay, so if I wanna find the determinant of this without rewriting my rows, okay, here's how you do it. You start the same way. 4 times -2 times 1. So -8, okay? Plus -1 times 1 times 0. Okay, it loops around to get the third one, which would be 0. Plus 2 times 5 times -3, it loops around. So 2 times 5 is 10, and 10 times -3 is -30, okay? And you're subtracting from it, you come back and do it this way. 0 times -2 times 2, plus, and this loops, 5 times -1 times -1, plus 1, wait, I lied, did I miss
No,
that?
that goes to 4, doesn't it?
This
Second
goes, yeah, it goes to 4. So 5 times -1 times 4, which is 20, -20. Plus 1 times -1 times -3, which gives you +3, yes? And you can solve determinant that way. Now, I don't care which way you do it, as long as you show me going through everything and whatever, okay? It's easier to write the two columns out and do it because then you just don't mess things up. You just go diagonal 3 in a row, okay? You never loop and mess something up. So it's kind of up to you. You can decide which way you wanna do it. But tomorrow, we're gonna talk about Cramer's rule and using determinant with Cramer's rule to solve linear systems, okay?